Alright, this is Michael Magera with Team Skynet again. My earlier work was with the OpenCV motion vectors with GPU acceleration, and here is the platform that I chose to use. So this right here is my Raspberry Pi 2, is presenting a video interface using MJPEG video streaming of JPEG files through the browser. I have a user interface down here. That's the arrow moving forward, stopping in the center, backwards, and a left-right. We have a compass device, which you can see up here. We have a heading of 261 degrees off magnetic north. We have a 3-axis gyroscope that's in the system as well, and we have an ultrasonic rangefinder. That interface, I'm using a polling using JavaScript, and this is my polling interface updating in real time when I hit it. Over here is the Raspberry Pi hooked up, my web interface, and then here is the actual robotic unit. I am going to swing back around for a second, and I'm going to go through the moving forward, stopping it, and moving it backwards. There's forward, stop, reverse, stop. In order for you to move left or right, you have to already be in motion. So I'm going to turn it on for going forward. And then you're going to notice that the tire, we're going to accelerate on one side. And then stop. So while in motion, you can move one of the tires forward. This is a limitation of these particular DC motors. They have to have a certain amount of juice in them before they're going to get into motion. This is a consequence of some of the issues I've been having with the 9 versus 12 volt power supply and swapping it out. So this is the platform that we're choosing to use. Let me give you a little bit of a walkthrough of the hardware. This top section here is the Raspberry Pi, and it's just a standard Pi 2. I have a Raspberry Pi camera. Next to it, I have a 3-axis gyroscope. This right here is a an ultrasonic rangefinder. And then as far away as I could get it from all of the motors is this up here, which is a magnetic compass. The underneath the Raspberry Pi is the Arduino Uno, and it's a little bit hidden down in there, but it's what's actually running the motors. When we look down on the front of this, we have 2 DC motors, 3.7 volt, and that's what runs the unit. In order to reduce the torque, in the first version I had treads, and I also had a 4-wheel design. In order to reduce the amount of work that those motors had to do, we just threw a swivel wheel on the back, and that reduced the amount of work the system had to do and let us move forward. One additional thing, this right here is a shield for hooking the Arduino to the Raspberry Pi, and it provides a serial interface. The built-in serial interface from MakeBlocks does not work. However, there are a couple of people who've done some work on building newer libraries, myself included, and it is a very convenient way of communicating between the two systems, but the default libraries don't work quite as advertised. This is part of a LiPo battery pack. I'm not using it right now, but a 6600 watt hour three battery system can be put in here, hooked up, and that will run the Raspberry Pi. This is 12 volts worth of rechargeable batteries. I'm not really good at soldering, but I put together a quick and dirty means of getting this. You can see my rubber band and my little twisty ties trying to hold things together. Well, this is my robot, and this is my system, and hope you enjoyed listening to it. If you have any questions, go ahead and post them in the YouTube section, and I'll be happy to share what I can about this particular system. This user interface that I have here is quite rudimentary, but it does allow you to do some debugging. I have not spoken very much about the firmware that was used to communicate between the Raspberry Pi and the Arduino. The Arduino firmware took a while to debug, and I'll probably put that in my paper for my class and probably put some notes out there along with the code for this project. Thank you, and talk to you later.